Hello everyone and welcome to another session on polynomials part 2. So basically if you remember from our previous class, we had a class on polynomials. We actually had 3 classes on polynomials, where the first 2 classes dealt with the basic explanation on what is zeros of a polynomial, what do you mean by degree of a polynomial, how do you find zeros, relationship between zeros and coefficients of a quadratic polynomial and a cubic polynomial. So this was what was covered in class 1, and the problems, CBSE problems on that, were covered in your class 2. So in the class 3 we had worked with what is the geometrical meaning of zeros of polynomial, and what is the division algorithm of polynomials. So that was what was done in class 3. We had done a few problems on that. So today what we are going to do is we are going to take all the CBSE problems that have appeared on this particular section, and we're going to work out through them. If you have any further problems, if you want us to solve some problems and you have any further questions on this particular topic, please leave a comment on the YouTube comment in the comment section, or you can visit our website, that is beyonds.org, where following this class you will have an assignment that will give you further problems on this particular section, where you can solve those problems and see immediate feedback on those problems, and basically judge or ascertain how well you have learned this particular topic. So without further ado, let's jump into the first problem. We're going to deal with 7 problems today. The first problem is, what real number should be subtracted from the polynomial 3x cubed plus 10x square minus 14x plus 9 so that 3x minus 2 divides it exactly. So basically what are they asking for in this particular problem? They're saying that you need to divide this particular polynomial by this polynomial so that you get some remainder, and that's the remainder that you should be subtracting from this particular polynomial so that this divides this exactly. So how do you do this? First of all, you write this dividend. As I've always said, before you start working on a problem, always write down the problem properly, because quite often then you'll have problems later on when you're in a hurry, specifically during a time crunch during exam, you might have problems. Okay. So first let's write it down. This is the dividend, this is the divisor. We need to find the quotient. So 3x into what will give you 3x cube? X square, right? So this is going to be 3x cube, and minus 2 into x square is going to be minus 2x square. Change the signs. This is going to be 12x square minus 14x plus 9. 3x into what is going to be 12x square? Plus 4x. 12x square minus 8x, so that's going to be, reverse the sign, and this is going to be minus 6x plus 9, and 3x into what is going to be minus 6x, minus 2, so minus 6x plus, plus minus 2 into minus 2 is plus 4. Reverse the sign. All this got cancelled. What's remaining is 5, right? So 5 is that number. Answer is 5. 5 is that number that needs to be subtracted. Maybe you could write it a little bit more elaborately. 5 needs to be subtracted, reduced from 3x cube plus 10x square minus 14x plus 9, so that it's perfectly divisible by 3x minus 2. If you see in the next slide, that's what we've done. We've come to the same conclusion. It's the same 5 remainder that we're working with here. All right. So now let's go over to the next question. That's problem 2. If the polynomial x raised to 4 plus 2x cubed plus 8x square plus 12x plus 18 is divided by another polynomial x square plus 5, the remainder comes out to be px plus q. Find the values of p and q. Now this is going to be pretty straightforward because you know how to do long division. So once you've done long division, whatever remainder remains, that has to be put into this format, px plus q, and then you can find p and q. So first of all, write this down. The dividend is x to the power 4 plus 2x cube plus 8x square plus 12x plus 18, and this needs to be divided by x square plus 5. You get, so what when multiplied by x square gives you x raised to power 4, x square, x power 4, x power 4. 5 into x square gives you plus 5x square. Subtract, remove the sign. You get 2x cube plus 3x square. 8 minus 5 is 3x square plus 12x plus 18. What when multiplied by x square gives you 2x cube, that is 2x. 2x cube plus 5 into 2x is 10x. Reverse the sign, this will get cancelled. You'll get 3x square plus 2x plus 18, right? Now what when multiplied by x square gives you 3x square, so plus 3. 3x square plus 5 3s are 15. Minus, this gets cancelled. 2x plus 3. So P is equal to 2, Q is equal to 3. That is what the solution is to this particular problem, because you're basically going to say that Px plus Q is equal to 2x plus 3, therefore your P is equal to 2 and x is equal to 3. Alright. So now if you go ahead and see the next screen, that's what we've done. P is equal to 2, Q is equal to 3. If you have any problem understanding my handwriting earlier, please feel free to have a look over here, pause over here and have a look at this particular slide. Alright, so let's start with the next problem. That's problem 3 of this particular class. So it says that on dividing this particular number x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient is this and the remainder is this. Find g of x. So what do we know? We know f of x is equal to x cube minus 3x square plus x plus 2. We know q of x is equal to x minus 2, and we know r of x is equal to minus 2x plus 4. We also know f of x is equal to g of x into q of x plus r of x, which means g of x is equal to, this implies g of x is equal to f of x minus r of x divided by q of x, which is equal to nothing but x cube minus 3x square plus x plus 2 minus of minus 2x plus 4 divided by x minus 2, which is nothing but x cube minus 3x square. Minus into minus, this was plus 2x plus x becomes plus 3x plus 2 minus 4 becomes minus 2 divided by x minus 2. Right? So now let's do a long division. When we do a long division of this, we are going to get g of x. So x cube minus 3x square plus 3x minus 2. This when divided by x minus 2, what will it give? So x has to be multiplied by something to give you x cube. What's the quotient? X square. X cube and minus 2 into x square becomes minus 2 x square minus x square plus 3x minus 2. X into something has to give you minus x square, that will be minus x square. Minus 2 into minus x will become plus 2x. Change the sign. This gets cancelled. X minus 2, and you know x minus 2 into 1 will give you x minus 2. Reverse the sign. Everything gets cancelled. This becomes 0. So basically x square minus x plus 1 is equal to g of x, right? If you see, this is what we've solved in, and we've got over here as well. G of x is equal to x square minus x plus 1. Alright. So now let's go over to the next problem. Problem 4. Obtain all zeros of the problem, and this is the problem. Find other zeros. So if you remember what I said last time as well, finding zeros of a biquadratic polynomial, that's a polynomial that is raised to the power 4, is very difficult. And the only way to do that is to first of all convert it, simplify it into a quadratic polynomial. How do we go solving about this particular problem? We know that 2 plus root 3 and 2 minus root 3 are roots of this particular, or zeros of this particular polynomial. How do we find an equation that consists of 2 plus root 3 and 2 minus root 3? We know alpha is equal to 2 plus root 3. We know beta is equal to 2 minus root 3. Alpha plus beta is equal to 2 plus root 3 plus 2 minus root 3. That's 4. Alpha beta is equal to 2 plus root 3 into 2 minus root 3. That's 4 minus 3 is equal to 1. So you could always write this as an equation: x square minus alpha plus beta x plus alpha beta, which is nothing but x square minus 4x plus 1. So x square minus 4x plus 1 is a root of this particular polynomial, right? So now let me try dividing this particular polynomial by x square minus 4x plus 1 so that we can find 0 or another quadratic polynomial whose zeros we can find. Alright, so we need to do long division. Do we have space here? Yes, we have space here. How do we do this long division? X raised to 4 minus 6x cube minus 26x square plus 138x minus 35 divided by, what's the number we got? X square minus 4x plus 1. X square minus 4x plus 1. What when multiplied by, give me one second, what when multiplied by x square gives x power 4, x square. So x power 4 minus 4x into x square becomes plus, that becomes minus 4x x square, minus 4x square plus 1 into, minus 4x into x square becomes minus 4x cube, x square into plus 1 becomes plus x square, minus plus minus, cancel this becomes minus 2x cube minus 27x square plus 138x minus 35. If I multiply this by minus 2x, I will get minus 2x cube, minus 2 into minus 4 is plus 8, correct? Plus 8x square, and this will become minus 2x. So this will become plus minus plus. So 27, 28, 29, 30, 35x square minus plus 140x minus 35. So that becomes, if I multiply this by minus 35x square by minus 35, I'll get minus 35x square. 35 into 4 will become 35 into 4 is 5 4s are 20, 4 3s are 12, 13, 14. So that becomes plus 140x minus 35. Reverse the sign, you will get 0, right? So what will be the other equation, remaining equation? Remaining equation will be x square minus 2x minus 35. Now two numbers when multiplied should give you minus 35 and when added should give you minus 2. What are those numbers? X square minus 7x minus plus 5x minus 35. Simplify this, take out common factors. I am taking x common from these two, so x into x minus 7 plus 5 into, I am taking 5 common from these two, so x minus 7 is equal to 0. X plus 5 or into x minus 7 is equal to 0. We know that it means either x plus 5 is equal to 0 or x minus 7 is equal to 0. So x is equal to, either it has to be minus 5. If I take 5 to the other side, it becomes minus 5. If I take 7 to the other side, it becomes 7. So the remaining two roots are either minus 5 or 7. So if you go ahead and see, that's what we've got over here as well. Minus 5 or 7. Alright. Now let's go over to problem 5. Problem 5, obtain all zeros of 3x raised to power 4 minus 15x cube plus 3x square plus 25x minus 30 if two of its zeros are root 5 by 3 and minus root 5 by 3. How do we solve this equation? So we know that since root 5 by 3 and minus root 5 by 3 are zeros of this, we could also say x minus root of 5 by 3 and x plus root of 5 by 3 when multiplied together will give you f of x, which is a divisor of this particular polynomial. So this gives you x square minus 5 by 3, which is nothing but 3x square minus 5 by 3. Now let's divide 3x power 4 minus 15x cube plus 13x square plus 25x minus 30 by this beautiful number called 3x square minus 5. So we know 3x square into x square will give you 3x power 4 and this will give you minus 5x square. Change the sign, minus 15x cube plus 18x square plus 25x minus 30, 3x square into minus 5x will give you minus 5 3s are 15 x cube, 5 5s are, this will give you 25x, right? Change signs, this will get cancelled. You have 18x square minus 30, and 3 6 are 18 will give you 18x square minus 6 5s are 30, reverse sign, this will give you 0, right? So you know that x square minus 5x plus 6 is a factor of this particular number, right? So now let's solve for x square minus 5x plus 6 is equal to 0. What will be the two numbers which when multiplied gives you 6 but which when added give you minus 5? So that's x square minus 3x minus 3 and minus 2. Right? We took common factor x out and minus 2 out. Now that means this is how it should be 0. That means either x minus 2 is equal to 0 or x minus 3 is equal to 0, which means x is equal to 2 or 3. These are the additional two roots of this particular polynomial. If you go ahead and see, that's what we found over here as well. Sorry, x is equal to 2 or 3 are the additional two roots of this particular polynomial. Alright. Now we're going to start on problem 6. Problem 6 says that obtain all other zeros of this if two of its zeros are root 5 and minus root 5. So this is pretty similar to that one. We know that if these are the two zeros, then x minus root 5 and x plus root 5 are two factors which when multiplied together will give you a polynomial that is a divisor of this particular polynomial. So we know when these multiply together, this is of the form a square minus b, a minus b into a plus b, this is a square minus b square. So you get this. Now x power 4 plus 4x cube minus 2x square minus 20x minus 15 when divided by x square minus 5. So what will you get? X square, x power 4 minus 5x square plus minus 4x cube plus 3x square minus 20x minus 15 plus 4x cube minus 20x, okay, and 3x square minus 15 is what remains. X square when multiplied by 3 will give you 3x square, 5 3s are 15, reverse the sign, you get 0. Which means that you know that x square plus 4x plus 3 is a factor or it is a divisor of this thing. So now if I solve for this being equal to 0, I'll get zeros of this particular divisor which are also zeros of this particular dividend. So what are the two numbers which when multiplied give you 3 but which when added give you 4? That's 3 and 1. Right? So this can be written as this. X square plus 3x plus 1x plus 3 is equal to 0. Let's take out common factor. X is a common factor between both of them. So when x into x plus 3 will give you x square plus 3x plus, if I take 1 as a common factor between this, I will get 1 into x plus 3 is equal to 0. So this becomes x plus 1 into x plus 3 is equal to 0, right? That means either x plus 1 can be equal to 0 or x plus 3 can be equal to 0. That means x is equal to either minus 1 or minus 3. Right, and these are the additional two zeros of this particular equation. If you see, that's what we've done over here. We've got minus 1 and minus 3. Coming towards the last problem of this particular session, problem 7, that is if 2 and minus 2 are zeros of the polynomial this, find all the zeros of the given polynomial. Pretty much on the same line, you know that f of x will have two roots. If 2 and minus 2 are two zeros, then x minus 2 and x plus 2 can be considered to be factors of that particular polynomial. This is the form a minus b into a plus b, so this gives you x square minus 2 square which is equal to x square minus 4. Now since x square minus 4 is a factor of this, when I divide this dividend by this x square minus 4, I will get a quotient, which and the zeros of that quotient will be also zeros of this particular dividend. So now let's convert this into a simpler quadratic polynomial, because when I divide this, I'll get only a quadratic polynomial. X power 4 plus x cube minus 34x square minus 4x plus 120 x square minus 4. X square into something needs to give you x power 4. That's x power 4 minus 4x square. Right? Change the sign. x cube minus 30x square minus 4x plus 120. X square into something has to give you x cube, that's plus x. X cube minus 4x minus plus goes away minus 30x square plus 120. X square minus into minus 30 will give you minus 30x square minus 4 into minus 30 is plus 120. Reverse the sign. This gives you 0, right? So that means x square plus x minus 30 is a factor. It's a quotient of this particular dividend divided by this divisor, which means that factors of this are also factors of that particular polynomial or zeros of that polynomial. So x square plus x minus 30. What two numbers when multiplied give you minus 30 and when added give you x? That's 6 and 5, right? So this can be written as x square plus 6x minus 5x minus 30 is equal to 0. Remove all the common factors. So x is the common factors between these two numbers, so it gives you x plus 6 minus 5 is the common factor between these two numbers. So when you remove that, you get this. That means x plus 6 is equal to 0 or x minus 5 is equal to 0. That means x is equal to minus 6 or 5, right? This is what the solution to your problem is. If you go ahead and see, that is what we've done over here as well. And when we divide, we are getting 2 and 5 and minus 6, right? These are the additional two roots of this particular equation. With this, we come to the end of our problems. Please let us know how you liked it. If you want any other problems to be solved, please leave a comment in our YouTube channel, or and after this, please do visit Vyans.org because we have an assignment for you there on this particular section. So it will give you a clear understanding of what you've understood on this. So keep studying hard and best of luck. Thank you and have a good day.